The Science Show!
Yo, what up? It's your boy Professor Pi on The Science Show. Totally not a ripoff of Bill Nye, by the way. Today, me and my associates will be explaining the process of dust and gas in a nebula rubbing together, creating and spreading electrostatic forces. Here we have some dust particles just floating around in the nebula, you know, hanging out. And once these dust particles rub against each other, electrons are being transferred. Therefore, they start sticking to stuff, like walls. And since both of those particles got a charge, they are now connected and will become one particle. And then those particles will get with more particles, and then eventually gravity will start taking over. Bye-bye. Okay. What up? Professor Pi, back again. Glad you could stay. Glad we didn't cringe you out earlier. But here's our ball of gas, and it has enough of those dust particles that gravity will eventually starting coming toward the center of the gravity, which is in the middle. So that means, see, let's get a close up. So here's a ball of gas with all these dust particles, and see, as more gravity comes, it squishes towards the center. Squish, 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 squish. Because clumps are being equally pulled on all sides. Got it?
Yeah, go for it.
Okay, welcome back. Volume 3. Glad you can stay with us. Remember our ball from before? Well, this is the ball just in a bigger form, so we can visualize what I'm about to show you. So, when the clump of gas and dust particles come together toward the center of gravity, it has a little spin to it. When the ball gets smaller and smaller, and more heat and more pressure come, it spins faster. Now that is due to the law of angular momentum, and that also has to do with the moment of inertia, or the mass of a spinning thing, the concentration of mass coming together more. Therefore, the angular velocity will increase when when the distribution of mass decreases. What this also does is when you spin it super fast, like it would in the universe, pull it up, it starts to bend into a disk, and that is due to centripetal force. As the ball is accelerating toward a radius, the outsides get pulled on, and it creates a disk. Ta-da! We have our nebula, and as you can see, it's full of particles. See the particles? Those particles are like atoms and stuff, and protons. So within the space, the atoms don't collide that much. You can hear them colliding against the surface. However, they do not collide that much. But when combined to a smaller space, due to the ideal gas law, the atoms will collide more. Here we have a much smaller space, so the atoms collide a lot more. What that does, it emits heat. Once that heat is emitted, the star is born due to the colliding of particles, and once hydrogen, which is the first atom, collides, it creates helium, and so on. And that process of nuclear fusion is what ignites a star. So, in other words, we have particles bouncing against each other, making heat, combining into bigger elements. That's what keeps a star going. That's what starts a star. And that's why the energy outward is equal to the gravity inward. That's why the star is able to stay place in a solar system.
Okay, go.
What up? Professor Pi here again. It's our last episode. It's really sad. Get your crying out now, because I'm about to blow your mind. So here I have a star, and the star that we made earlier, and it's spinning and stuff. But all these marbles all this residual material is still with the star. However, due to solar winds and energy emitting from the star, they scatter everywhere. And they're also rotating as well, because obviously law of conservation of angular momentum. And these particles coalesce into what we perceive as planets. So these would combine into a planet, these would combine. However, there is a line called the frost line that goes around the circumference like so, and the planets outside the frost line, hydrogen is no longer in a gaseous state. It's something to note. And after all these particles have combined into planets, we have our present-day solar system. So we've gone to like a bunch of gas in space to a solar system.